Yeah.
I don't know what that means. Anyway, where would you like to, how was your Thanksgiving? Was it good?
Yeah, it was good. I had my grandparents over.
Huh? That's nice. That's almost
Hmm.
my favorite holiday of the year is Thanksgiving.
What's your favorite?
I said Thanksgiving probably is. Yeah, I love the food.
Yeah.
But, all right. So, you tell me where you want to begin. I noticed there's 3 pages. We probably have a lot of problems to cover here.
Yeah, number 1.
Okay. Let's, you might be able to figure this out without drawing it, but I'm not good enough to be able to do that, I don't think. 2, 4, 2, 7. Okay, at least we have a vertical line. That's nice. And then 10, 7. Now we can see that that's going to be a line that is parallel with the x-axis. That's a
Hmm.
vertical line. So I can kind of guess what the last one's going to be. 10, 4, and it is. And what do we have?
A rectangle.
Yeah. And when they say the most descriptive, that actually is a number of things. It is a quadrilateral. It is a parallelogram. But the most descriptive is it's a rectangle. In other words, not all rectangles are parallelograms or quadrilaterals. But I'm sorry, I said that backwards. Um, not all parallelograms and quadrilaterals are rectangles. That's what I meant. All right.
And then number 2.
All right. Okay, so we have AB congruent with DC. So let's see what that allows us to do. What can we do from that?
2x plus 5 equals 4x minus 17.
Solve that. You will find that algebra is every bit as important in geometry as geometry is. It comes down to every problem as half algebra, half geometry. So how would you solve that equation?
You would just, I would take the 2x first, so subtract the 2x from the first side.
Okay,
And then,
that's going to leave 2x over there.
and then add the 17 to the negative 5.
That's going to leave that. X equals 6. Now, they ask us to prove that it's not a rhombus. Well, a rhombus means what?
All these sides are the same length.
Okay, so it's all we have to do is prove that that is, or excuse me, is that is not that. Well, if we substitute, we know what x equals. X equals 6. So if we substitute that, we get 24 minus 17. We get that side is 7. Ooh, hold on a second.
Would it be 18?
What did I do?
I think
6 times 4 is 24 minus 17 is 7. Then up here I get 17 I did the math wrong. Notice that I got 2x minus 5. It should have been 2x plus 5. It's because I had the sign covered up with my writing. So let's go back and do this properly. That's why it's always good to check your math along the way. It's because when you get to the end of a problem and you discover a problem, it's hard to figure out where you made your mistake. But if you check it at each step, now it's a little easier. Now it's equal to 22, x equals 11. So this side here would be 22 plus 5, 27. This side here would be 44 minus 17, 27. But this side here would be what? 31.
32, yeah.
Well, as long as it's not 27, that's not a rhombus. And that is 27. And they clearly have not drawn it to scale. So the only way to prove it's not a rhombus is algebraically. Okay. Number 3, are we just going to go in order, or are you going to pick and choose?
Yeah, just go in order for now, I guess.
For the rectangle, in order for this particular RECT to be a rectangle, what must the value of x be?
Wouldn't you just do 2x plus 6 equals 42?
No. First of all, for that to be a rectangle, that has to be 90 degrees.
So yeah, okay.
So start again.
It would be 2x plus 6 plus 42 equals 90.
Okay, which means that's equal to 48. Which means 2x equals 42, which means x equals 21, which means that angle is 48. So now, I guess that's all we need to show. They didn't really say prove that it's a rectangle. They just said that if it's a rectangle, figure out what x is. So the only angle we have to deal with is that one right there. In other words, that thing cannot be a rectangle if x is not equal to 21. X being equal to 21, incidentally, I'm not sure that proves that's a rectangle. It proves that's a right angle. We have this side equal that side, and we have that side equals that side. I guess that proves it's a rectangle. It's immaterial. I'm not quite certain that that proves it's a rectangle, but it certainly answers this problem. Let me scroll down to the next. Screen sketch doesn't want to work. Hold on. Try that again. Well, make sure I'm recording. I am. Let's check it again. There we go. Sometimes it's hit and miss. Okay, what's the most descriptive name for a quadrilateral with the vertices those? Now, I'm not certain we need to graph this. We can see that the y-coordinates are the same on 2 points, which would indicate a vertical line. We can also see the y-coordinates are the same on those 2 points, so that's a vertical line. We can also see the x-coordinates are the same on those 2 points, so that's a horizontal line. And the x-coordinates are the same on those 2 points, so that's a horizontal line. So however this thing maps out, I don't need to take the time. I got 2 horizontal lines and 2 vertical lines. It's hard for it to be anything other than that. So what's the only question?
If the sides are equal.
Yeah, is it a rectangle or is it a square? Well, what's the distance between the x coordinates?
The x coordinates.
Yeah.
For which?
Take these 2 x coordinates right there. What's the distance between those?
-11 and 7, so that would be 18.
Okay, so that side's 18. And the difference between those 2 x coordinates is 18.
So
We
it
look
has
at the
to be
difference between the y coordinates. What is it?
0
No,
for both.
5 and 13 are the 2 y coordinates.
Yeah. 18.
So what is this?
Square.
It's a square, correct. So I didn't really need to go to all that trouble. Once you do that a couple of times, you kind of get a hang for it. It's probably safer if I was taking a test, I would probably have plotted those out. Just approximately, though. Never waste much time doing it exactly. You don't need to do it exactly. You certainly don't need to do anything like grid it up. In other words, this would just be a waste of time. Almost never do that. It's almost always correct to just approximate. All right, number 5. So what's the expression for the area?
9x times 2x minus 5.
In parentheses. You do need the parentheses there. Okay, what's the expression for the perimeter?
9x squared.
Not
plus,
squared.
Or
times 2.
Yeah, times 2.
In other words, this is 9x. So it's 9x plus 9x. That's different than 9x squared.
Yeah.
Plus what?
Plus 2x minus 5 times 2.
Yeah. And when you are verbalizing that, you want to do that a little different. You either want to say the quantity 2x minus 5 times 2, or you want to say left paren 2x minus 5 right paren times 2. But if you verbalize it, 2x minus 5 times 2, I could write that as this way, 2x minus 5 times 2, which is not the same. Okay? That's one advantage of online tutoring, is you actually get practice in verbalizing stuff, which is unusual. You don't probably get much practice at that when you're in class. How often do you stand up in class and verbalize a problem? Probably never.
Actually, every day.
Oh, you're kidding, really?
Yeah, we each get a problem to do from our homework to verbalize.
I'll be darned. Well, good for your teacher. I like that. Because I do think there's things to be learned by verbalizing these problems. Not just the way you word it, but the way you think about it, I think, is helped by verbalizing it. All right. You have any problem with that?
No.
Let's move on. Is that all there is to this one?
Yeah, because that's the only problem that I have to do.
It was funny. This was the one I happened to look at on my phone. And I figured my phone was screwing it up because I wasn't sure that this didn't look like a typical problem. I figured I was missing some information. I guess what it is just four problems, huh? I kind of get it now. So, okay, now I get it totally. So what's the most descriptive name for a quadrilateral with diagonals that are perpendicular bisectors of each other?
That could be a square.
Is that the most descriptive?
Uh,
In other words, it's certainly true. It's not true of a rectangle, incidentally. If you draw the diagonals on, and if you ever want to figure this stuff out, when you're drawing rectangles, draw your rectangles like this. In other words, elongate them. Because that kind of shows you that the diagonals on a rectangle are not perpendicular. They may bisect one another, but they're not perpendicular, which is very clear when I elongate the rectangle. Okay. Well, a square, certainly, those are right angles, and they do bisect one another. But there's one other shape that also does that. Now, I got to think about it for a moment to figure out which is the most descriptive. I think you would have to use the second one that I'm thinking about. Might be wrong, but what other quadrilateral has the diagonals bisect one another? Ah, it's not true. I was thinking of a kite, but they don't do that. No, one diagonal bisects the other, but the top one does not bisect the bottom one. So I guess you're right. Square is the only one I can think of. A rhombus, maybe? Let's see. If I draw a rhombus that's not quite like a square, that would be a kite. In other words, if you draw a rhombus that's no, can you draw a rhombus that's not a square? Yeah, you can. You know, what happens if I draw a rhombus? Well, the question is, I got a feeling those do bisect one another. And they are perpendicular, and yet that is not a right angle. So that is not a square. Yeah, in other words, if I elongate the diamond like that, all four sides are equal. Definitely not a square. But I'd bet anything those are perpendicular bisectors. So, what would be the most descriptive name?
Rhombus.
I think so. In other words, not all rhombuses are squares. All squares are rhombuses, but all rhombuses have that as true statements. So that would be the most descriptive, I think, would be a rhombus. I can't think of a way to draw a rhombus where the two diagonals do not bisect one another. And the difference between a rhombus and a kite is obviously a kite only has two equal sides.
Yeah,
it changes everything. So, okay, so that's a rhombus. And number two, a rectangle that is also a kite.
Isn't that also a, could it be a rhombus?
Well, let's see. If we look at a normal rectangle, there's no way that's a kite. Because for a kite, two adjacent sides have to be equal, right? In other words, that's the first rule of a kite, is that two adjacent sides are equal. So if I have a rectangle The only way that a rectangle has two adjacent sides equal is if it's a square. And I think that's got to be the answer. In other words, that is the most descriptive. Obviously, the answer isn't going to be rectangle or kite, because not all kites are rectangles. The only rectangle that's a kite, I believe, is a square, unless you can think of one. No, these are the only two kinds of rectangles you have, either squares or long ones. And the only one of those that is a kite with two adjacent sides that are equal, those two and those two, happens to be a square. Okay. Quadrilateral with one pair of opposite sides congruent and the other pair of opposite sides parallel.
Trapezoid?
No, a trapezoid has one opposite sides are parallel, but the other two opposite sides are congruent. If you had an isosceles trapezoid, that might be the answer. And that's better than trapezoid. In other words, usually I assume what they mean by the most descriptive name is, in other words, the only thing that fits that description is an isosceles trapezoid, not all trapezoids. But let's think about this for a second. Opposite sides are congruent and opposite sides are parallel. Well, parallelogram also fits that description, kind of. I mean, it definitely does. There's the two opposite sides that are congruent, and those are the two opposite sides that are parallel. So technically, it does say one pair. It doesn't say one pair only, but I think that's what they mean. In other words, if I were to take a parallelogram, it's got two sides that are congruent, both opposite sides, and both opposite sides are parallel. So the wording he has here is a bit ambiguous. One could make an argument that that is also a parallelogram, but I think they're looking for isosceles trapezoid. All right. Do you have answers on these by chance?
No.
Okay. Wonder if Windows changed. All of a sudden, I'm able to magnify this 3 times without it rotating on me automatically.
That's good.
Which I love. Yeah, that's been a real problem for me. And all of a sudden I can do it. But now, also, all of a sudden, there it comes. My workspace wasn't working. All right. 13A. And the only thing I'm presuming that you can assume is what is on these diagrams.
Yes.
You can't presume by looking at it. So the only thing we know here is we have two sides that are parallel and opposite equal. They're parallel and equal.
So that'd be a parallelogram.
I think you're right. Yeah, I was sitting there thinking that, well, can I draw this so that these sides that are unmarked, do they have to be parallel and equal also?
Mm-hmm.
I think they do. In other words, this doesn't have to be a square or a rectangle, but it does have to be a parallelogram. If those two sides are equal to one another, then that means that is parallel to that. And now you have opposite sides are parallel, all four, that's a parallelogram. Okay? How about B?
A trapezoid.
Right. Because that side is parallel to that side because of those two right angles, but that side is not equal to that side, which sounds like a trapezoid, and we don't know about this side and that side. We don't really care. They don't have to be parallel. Let's see, can you draw trapezoids? Yeah, I can draw trapezoids that don't have any equal sides. C.
C is an isosceles trapezoid.
Yeah, that's like that previous problem. One pair of parallel sides and the other two are congruent. Isosceles trapezoid. Okay, D.
That could be a rectangle or a square.
That's the minimum it can be. It could be a square, but has to be a rectangle.
We cannot assume.
It has to be at least a rectangle, and they don't tell us anything about the side lengths, so we cannot presume it's a square. Okay. And number E.
That's also a rectangle.
Yeah, because they don't tell us anything about those angles. They don't tell us that they're right angles. And the only thing I know of, and if we draw an elongated rectangle, we see that it's true that that's a bisector, those diagonals are equal, so all four of those have to be equal. If we know nothing about this angle here, then we don't know how long that rectangle is. So it's just a rectangle. Now, could it be a parallelogram? If I draw a parallelogram, no.
Yeah, because it's longer from...
Notice that this last one I just drew is longer diagonal than the other one. So even though those bisect one another, they don't create four equal segments. Whereas this number E does. So it has to be a rectangle. How about F?
A rhombus.
I was going to say a kite. Remember a kite? Again, by elongating it, you can see a little bit more. Notice that that's equal to that. So much for a kite. It's not a kite. You said a rhombus. If I draw a rhombus in the form of a parallelogram, yep, we know that that's the same as that, and that's the same as that, and they're not equal. So, yeah, rhombus. How about G? Oh, and a rhombus also, yeah, 90-degree angles there.
I think it could be a kite, too.
On F?
No, G.
Oh, G. Here, let's look at G. Yeah, in a kite, these sides here don't have to be equal. So,
Mm-hmm.
but these two do, and it's always a right angle. So yeah, I think that would be a kite. These are pretty good problems. I like these. I haven't seen problems like this very much.
Mm-hmm.
Teaching geometry must be the fact that your honors geometry, you always get a little different kind of problems.
Mm-hmm.
And H
Is a quad.
is that the minimum thing it is? In
Uh,
other words, are all quadrilaterals have, here's a quadrilateral. If I draw the diagonals on it, I don't see where any one of them bisects the other.
mm,
Unless it's just the way I've drawn it. Could be the way I've drawn it. Why do you think it's just any old quadrilateral?
because that's like the least specific.
Uh-huh.
So
Well, let's see. It's not a rectangle because we know those two lines would be equal. It's not a parallelogram because those two pieces, everything would bisect one another. How about a trapezoid? If it was an isosceles trapezoid, they would both bisect one another, I think. I'm not even sure they do bisect one another.
mm-hmm.
I don't think they do, actually. So you think it's just any old quadrilateral, but no, I just drew a quadrilateral where it didn't appear to be true. Let's see if I can draw one bigger and weirder so that we can figure out for sure whether it's true or not. So there's a quadrilateral. 1, 2, 3, 4. Now let's draw the diagonals as accurately as I can. I don't see anything bisecting anything. In other words, it's not just a quadrilateral.
Mm.
Because I can draw a quadrilateral that's not true. Where, one diagonal is not bisected. So,
Mm-hmm.
question is what is it? Kite? Certainly a kite. That's true. In other words, one diagonal only is bisected, but you also have right angles, but the fact that they didn't show that, I'm not sure that matters. What other figures is only one diagonal bisected?
Mm.
Kite is the only one I can think of.
Yeah.
Parallelograms, they both bisect one another. Trapezoids, I don't think either one of them bisect one another. Even maybe, no, isosceles trapezoids, no. Maybe a regular? Let's see, if I draw a trapezoid, it's really exaggerated. No, those don't come close to bisecting one another. So trapezoid, no. Only thing I can think of is a kite. In other words, you want the most specific, and in other words, quad can't be the answer because it's got to apply to all quadrilaterals, correct?
Mm-hmm.
And I can draw a quadrilateral that's H is not true on. I cannot draw a kite. I cannot draw a kite where H is not true.
Yeah.
So I would have to say kite. That may not be the right answer. There might be something more specific. I'm just not thinking of it. I suppose you could even say parallelogram. but not all parallel. No, all parallelograms both bisect one another, no matter what it is. Yeah. So this is the only one I can think of that fits that picture perfectly. Yeah, let's go on. If you think of some other ideas on that, holler. All right. Number 14. Let's just first check to see if we got stuff that's the same. The only 2 points I can see that are the same are those two. I don't see anything else that's the same. So it's not going to be a rectangle. So we better plot it. Okay. Minus 7, 2. 2, 8. 6, 2. And minus 3, minus 4. So here's what we're looking at. What do you think it probably is, just as a guess?
A rhombus?
I would say a parallelogram.
Yeah.
And the way I'm going to prove it, and the only reason I say that is because that'd be the easiest thing to prove. How would we prove it's a parallelogram?
The slopes.
Okay, what's the slope of this line right there?
2 minus 8 equals 6 over 6 over 2/3.
2/3. Now let's look at this one.
6 over 9. So 2/3 again.
So that line's parallel with that line. Now let's check the other two slopes. If the other two slopes are also parallel, then we could say it's a parallelogram, and then we'd have to check maybe a little bit further to see if we have right angles or anything. What would tell us whether we have right angles or not? What do we know about slopes of two lines that are at right angles with one another?
The negative reciprocal.
Okay, so let's figure out the slope of this top right line here.
Okay, so that'd be 2 minus negative 3. So that'd be 5 over negative 7 minus negative 3, which is negative 4. So it'd be negative 5 over negative 4, which is...
Hold on. I think you made a mistake in your math. First of all, did you get negative 2/3 for up here? I get 6 over negative 4. That's negative 3/2, not negative 2/3. And then for this line, the lower left one, what do you get for that slope?
6 over negative 4.
Okay, which is also negative 3/2.
Mm-hmm.
So since the slopes are the negative reciprocals of one another, what is this figure? What's the most descriptive name?
A rectangle.
Yeah. Two opposite sides that are parallel and 4 90-degree angles.
Mm-hmm.
I'm not sure if there's other ways to prove that's a 90-degree angle. I don't think there is. The only method I can think of is using the slope definition. the slope of two perpendicular lines is one's the negative reciprocal of the other.
Mm-hmm.
I don't know any other way you'd be able to prove those are 90-degree angles. So 15. A is the midpoint, so that's equal to that.
Oh, we can go to 16.
Oh, you don't need to do 15?
Yeah, no.
Okay. 16. Find the area of the parallelogram. Hint, the area equals the base times the height. Oh, and this is at a no, it's not.
I got 88 units.
So you're getting a base of 12. And what are you getting for the height?
I got 8.
This distance right here? Oh, it's the vertical height, excuse me.
Yeah.
So it's this distance. It's this distance right there.
I got 8 for that.
I see 9. Oh, no, you might be right. Would you solve this triangle? Let's see. So, because this distance here is 9. Excuse me. How is that not 9?
Never mind. Yeah, it is. I just didn't. Yeah. I did the wrong coordinates for my picture.
So it's 9 times, this one's definitely 12, the difference between 5 and minus 7.
So it's 108.
108, I think, yeah.
Yeah, I drew it wrong on my paper, and then I was going off of that.
Yeah, this distance right here is greater than 9, obviously, but that's not the vertical height either. That's the slant height. And you always want to use the vertical height. Okay. And 17 next?
Yes.
Okay. Is symmetrical across both diagonals.
And that'd be a rhombus, right?
I'm not quite sure what they mean. What do they mean symmetrical across? Oh, they mean this side is symmetrical with that side, and this side is symmetrical with that side. Is that what they mean?
Yeah.
So any old rhombus?
I think so, yeah.
Let's see, that creates 2 symmetrical sides. That creates 2 symmetrical sides. Does it have to be a rhombus? Can it be a diamond? I mean, a kite?
I don't think it can be a kite.
Well, no, you're right. That does not create 2 symmetrical sides. A rhombus. A rhombus does, and that's less. All rhombuses would have some symmetrical sides opposite or across from both diagonals. Okay. If a quadrilateral is symmetrical across exactly one diagonal, it is what?
A kite.
Yeah. Got ahead of myself there. Which quadrilateral has 4 axes of symmetry?
The only one that has 4 would be square.
I think so, yeah. In other words, I can rotate that thing 90 degrees without it changing. And I can do it 4 times.
Mm-hmm.
And a rectangle you wouldn't be able to do that with. Wouldn't survive the first rotation. Now, does it have to be a square? A kite, no. No, that's not symmetrical, all 4 directions. The first rotation would leave something like that.
Mm-hmm.
So, okay, I'll go with square. Sometimes these things, you kind of have to just try all the various, at least that's the only way I know how to do it, is try all various possibilities, going more and more specific until you get the most specific one. Okay, Joseph, is that going to take care of you today?
I think, do you have one more page or no?
I don't think I do. Let me check. I don't think so. I opened up, hold on. What's that +1? We just did that one.
I think there's an arrow in the side.
Looks to me like I only have 3 documents here.
If you click on that one, not the one, but the 0098.
Oh, this says 4 attachments. Okay, hold on. Let me back up here. Let me learn something. What should I click on?
The image.
0098. Okay.
Mm-hmm. And then there's an arrow, a black arrow right there.
Right here on the right?
Mm-hmm. Then if you just click on it, there's another page.
Oh, that's weird. So anything greater than 3 shows up like that?
I would guess.
Is that what caused it to? Okay.
Mm-hmm.
Quadratic to represent the area of that.
So the area equals x squared plus 6x.
Okay, and if we have an area of 160 meters, find the perimeter.
Perimeter.
What do we have to do to find the? First of all, that's the area. What's the perimeter formula?
2x or x times 2 plus x plus 6 times 2.
So the perimeter is 4x plus 12. So what's our next step? In other words, we have the perimeter in terms of x, we have the area in terms of x. They gave us an area. They didn't give us a perimeter. So which one can we figure out? Which formula allows us to calculate x? The first one. Only the first one. Notice that in the second one we have 2 variables. We have p and we have x. We can't solve that. But in this one, we only have 1 variable, x.
Yeah.
So let's solve that quadratic. I'm going to bring the 160 over to the left. I gotta believe this. Whoops, excuse me, I didn't. factor that?
Mm-hmm. Ah, shit.
What's that mean?
Yeah, I set my alarm. The power went out last night, and I set my alarm for 5, and my clock's 8 minutes ahead.
Oh.
And yeah, the times
okay?
all screwed because the power went out.
You okay to keep going?
Yeah.
Okay. So how do we factor that? What's the next step in factoring?
Minus 160. Plus minus. We can do the
Plus minus, that's the second step. Because you can't produce a minus 160 without that. Now what we need are some factors of 160.
There's 10.
That have to do what? What do these factors of 160 have to do?
They have to somehow go to 6.
They have to subtract to 6.
Yeah, subtract. Yeah.
Okay. I'm going to do this the way I typically do it. I'm just going to keep breaking it down until I see two numbers that subtract to 6. Bingo. Whoops. Hold on. Bingo. In other words, I kept cutting the one on the left in half and doubling the one on the right. There's my two factors, 16 and 10. What's the 16 go with and what's the 10 go with?
The 16 goes in the second one.
The larger factor goes
in the
with
first.
the sign of the middle term. The sign of the middle term is plus. So that's where the 16 goes. And the way you can always check these is in other words, that middle term comes from the inside and the outside of the foil. Add those together, you get plus 6x. That's the middle term. We've done it correctly. Now, we're not quite done with this problem. What are my solutions to that quadratic?
X equals 16 negative 10.
No. If both of those multiplied together are equal to 0, the most important rule in all of algebra is that when you have two things multiplied together equal 0, then set each thing equal to 0. So I'm going to set x plus 16 equals 0, which means x would be negative 16. Or I'm going to set x minus 10 equal to 0, which means x equals 10. Now, which of those solutions is impossible? Look at the figure up here. That rectangle. It has a dimension of x. You can't have negative dimensions.
So it can't be the...
throw out the negative. Whenever you're doing geometry and you're solving a quadratic and you come up with one of them being negative, you throw it out. Because that fundamental rule of algebra says that if two things are multiplied together equals 0, one of them has to be 0. It doesn't say both of them have to be 0. Even though the way we usually solve it is both solutions, negative 16 and positive 10, work in that quadratic. They both satisfy that. But because it's a geometry problem and we're dealing with a dimension, you throw out the negative solution. Similar if you were dealing with projectile motion and you were looking at time. And you came up with a negative time and a positive time, you throw out the negative times. Can't have negative dimensions, you can't have negative times. So x equals 10, so what's the perimeter?
52 meters.
Yeah. And I think that's the only way you really can solve that. And we got a few minutes. Let me at least look at number 20 and see if we can solve it quickly. A rectangle has a vertex on the line. Okay, that's the point x comma y. The equation of the line is that. Okay. Find the area of the rectangle. What's the x-coordinate of that point? Look at the whole picture, including this down here. They've told us it's a rectangle, so the x-coordinate, where it says x comma y, what does that x have to be?
3.
Okay. So if that's actually 3, what's the y?
Negative 6 plus 17, which is 11.
Now what's the area of the rectangle?
11 times 3, 33.
Right. Okay. Let's see if we can finish 21. Circle P just touches its tangent on the x-axis. Find the area of circle P to the nearest hundredth. What's the radius of circle P?
The radius is touches.
Remember that all radiuses are equal. So if I want to know the length of that line, it's the same as the length of that line. What's the length of that vertical line that I just drew?
3.07 divided by 2, right?
And no, it's 3.07. In other words, the distance from there to there, that's 3.07.
Oh, yeah,
exactly one radius. Circle. It's not a diameter, it's a radius. So the area, what's the formula for area of a circle?
Radius squared times pi.
Okay. Tell you an easier way to remember it. Pi r squared, right?
Mm-hmm.
Pi are circular. They're not squared. So there's a ring to it. Don't remember it as the radius squared times pi. I mean, that's the same thing. But pi r squared, you'll never forget. There's a ring to it, plus pi aren't squared. They're circular. They're round. So it's an opposite thing also. So the area of that circle is pi times 3.07 squared. They want you to do that on your calculator, round it off to the nearest hundredth.
So it would be 29.61.
What was the third digit on your calculator? Because I can't tell if you rounded it off correctly or not.
3.
Was it a 3? What?
I erased the number off my calculator.
Can you do it? You want me to do it on mine? Well, you know how to round it off. If it's a 5, then the answer is 29.62. If it's less than a 5, then the answer is 29.61.
It was less than a 5.
Okay.
I remember.
That's all you need to know. So.
Yeah.
All right. Well, good. We got through everything.
Mm-hmm.
Very good, Joseph.
Yep.
Talk to you next time.
Mm-hmm. Thank you.